So today we're going to continue with circles and talk about sector area and arc length. So a sector is one of my favorite geometric figures. Why? Because it's shaped like a piece of pizza.
I like pizza.
You're going to say like pie or something.
Okay, you can do pie, you can do pizza.
You like pineapple on pizza?
With ham, yeah, it's tasty. All right, so a sector of a circle is bounded by an arc and two radii. So this colored in thing here, that's a sector of a circle. So a question for you, if the measure of the sector's arc or the central angle, remember those two are the same measure, is 120 degrees, what fraction of the circle's area does the sector take up?
1/3.
1/3. How did you get that? 360 divided by, yeah, so that's 3, not 1/3.
3 sections of the circle. 120. I don't know. I just.
Oh, okay.
Yeah.
120 divided by 360 is 1/3. Well, it doesn't always come out to be something quite so nice.
Unfortunately.
Right, what if it was like, 73 or something?
I would not like that.
It would be 73 3/60ths of the circle.
That does seem unnecessary.
All right, so then if we were looking for the area of this sector, what we can do is find the area of the whole circle and then multiply by what fraction of the circle it is. You can do that all at once with this formula. The measure of the central angle or the arc, either one, doesn't matter, divided by 360, that tells you what fraction of the circle you're dealing with. And then pi r squared is the area, not the circumference. Okay, so, indeed, find the area of the sector shown. All right, so the area of the sector, the formula, m over 360 times pi r squared. So that'll be 70 out of 360 times pi times 12 squared. Let's see, that's 7 over 36 times, and I'm not going to square the pi. I mean, square the 12 right now. I'm going to do 12 times 12 because I'm looking ahead, thinking to a time when I'm not going to grab my calculator for every little thing and go, oh, well, let's see, 12 goes into 36 how many times? 3 times. And then 3 goes into this 12 4 times, giving me an answer of 28 pi. Square centimeters. Okay? Any questions about that? Okay, related to a sector is a thing called a segment of a circle. So the segment of a circle is the region between a chord and the circle. So if I wanted the area of just this segment, what two areas do I need to find? Close, but not quite.
Area of the circle and area of the individual triangle.
That's exactly what Sammy just said.
Oh, I didn't hear her.
Yes?
Measure of the sector?
The measure of the sector?
Oh, the area of the sector.
The area of the sector?
And the area of the triangle.
Yes. The area of the segment is equal to the area of the sector minus the area of the triangle. It's not the whole circle minus the triangle. If it was the whole circle minus the triangle, you'd be including all this stuff out here.
Isn't the sector the shaded part though?
No, the segment is the shaded part.
So the triangle, well, so the is the sector?
I don't know what you mean by that.
The segment plus the triangle is the sector?
Yes.
Okay.
So let's see, the area of the sector, it's m over 360 times pi r squared. So it's 60 out of 360 times pi times 14 squared. Let's see, 60 over 360 is 1/6 times 14 times 14 times pi. Let's see, 7 times 14 is 98. So it's 98 pi over 3. Icky. And then, how can I find the area for this particular triangle?
It's
Equilateral.
Yes, it is. So,
S squared
each thing
times
is congruent.
yes, so,
S squared times the square root of 3 over 4.
yes.
Yep.
Side squared times the square root of 3 over 4. Or, remember the other way to do this is s over 2 squared times the square root of 3. Works out the same way. The second one is actually easier because then I can substitute in and divide. I'll have 14 over 2 squared times the square root of 3. So it'll be 7 squared is 49. So that's 49 square roots of 3. And the units on this were inches. Since this is area, that'll be square inches.
Are they making a third parking lot?
They're
Doing that one, the horseshoe.
Are they redoing the horseshoe?
Someone, I think this company, I think, told me that they're making more spaces over there and the horseshoe maybe the student parking lot. But I thought it was like plumbing.
Yeah, I
because
think
it was
so.
all on the ground.
I think they're making a little bit more space.
In the horseshoe? Gotcha. Sounds a little bit like someone's got a Tommy gun out there.
Sounds like someone has too much money and then burning a hole in their pocket.
What does that have to do with anything?
Why do we need that?
Do we need
It
more
seems like
parking?
a waste of money.
I agree.
For more parking spaces?
Well,
Since
there
we
are
don't
more
have
people-
enough?
It gives more accessibility to certain
But like there have been more people.
All right, so moving on to page 2.
Page.
So the length of an arc is the distance on the circle from one endpoint to the other. It's part of the circumference. So one thing you have to be careful of is that the length of segment RS is not the same as the measure of segment RS. The measure of segment RS is like 80 degrees or 120 degrees or whatever. It's how much bend it has to it. The length is the distance from here to here. If you were to, cut that out of the circle, straighten it out, and put it on a ruler. Yes, ma'am.
How do we know that it's going like the shorter way to RS, opposed to the long way?
Okay. When it's only 2 letters, it is automatically a minor arc.
If it's straight, it's the big way.
Pardon?
If it's straight, it's the big way.
Not necessarily. Like if I put point A right here and called this arc RAS, it'd still be the short way around.
Okay.
But usually, yes. But you can't make a rule that says all the time, if it's 3 letters, it's a major arc. It doesn't work that way. Okay? So the arc length formula is very much like the area of the sector formula. It's m over 360, but then it's times 2 pi r, which is the
circumference.
It's the what?
I'm just kidding. It's circumference.
It's the circumference formula. I kid about lots of things, but yeah. So let's find the length of arc JB. So what would the measure of arc JB be?
100 degrees.
100 degrees. But the length, arc length, is equal to m over 360 times 2 pi r. So that's going to be 100 over 360 times 2 times pi times 18. Let's see. Oh, 2 times 18 is 36. 36 into 360 goes 10 times, so this comes out to be exactly 10 pi inches. They don't always come out that nice, but that one happened to. Okay, any questions?
Who's your favorite dinosaur?
It's not Barney.
That's understandable. I thought Marty was like bad or something.
I find him annoying.
Never understood why all the kids were always there. Like,
Yeah.
I just didn't know why he always had